This device is called Newton's cradle, and we have three different examples here of how it might work. In the first example, top left, we lift one ball up and drop it. It'll swing down and hit the other balls. The question is, what will happen when it hits these three balls? There are three possibilities for how we can conserve momentum in this collision. One ball could leave with the same speed that the initial ball had when it swung down. Two balls could leave, doubling the mass and making the speed of them half as much as the original ball. Or all three balls could swing up with 1/3 of the velocity because it's 3 times the mass of the original ball. In the second example, we have two balls lifted up in the air. When these swing down, again, we could send one ball off with half the mass and twice the speed of these. Two could go off with the equal speed of these, or some other combination. This ball could join these two and go swinging off at some other speed. Here we have three balls lifted up in the air that are going to swing down and hit this one ball. And again, there are lots of possibilities for conserving momentum to have the one ball swing up with 3 times as much speed, two balls swing up with 2/3 as much speed, or three balls swing up with original speed. There are many different possibilities. However, only one actually occurs. So when we click run, we're going to get all three of these in motion at the same time. There they go. And you can see up in the top left corner, if we lift one ball, one swings off on the other side. In the bottom left corner, if we lift two balls, two swing off. And if we lift three, three swing off. So out of all the possibilities for conserving momentum, only one occurs. The question is, why? Well, it turns out that because of the kind of collision we're looking at here, which is elastic, not only do we have to conserve momentum, but we have to conserve kinetic energy. And the only way kinetic energy can be conserved is if the same number of balls swing back after the collision as we lifted up before the collision. So Newton's cradle is an ideal example of how momentum and kinetic energy are conserved in elastic collisions. One more time. So you can see out of all the choices that we have for conserving things, the only way this will work is if an equal number of balls swings off after the collision as we lift it up before the collision. And that's to conserve kinetic energy. It's kind of cool, huh?